Today we're going to look at thermal stress and a sample exam problem. So rod CD is made of aluminum and is housed in a rigid assembly. When the temperature is 30 degrees Celsius, the gap between the rod and the top of the housing is 0.1 millimeter. Determine the normal stress in the rod if the temperature rises to 130 degrees Celsius. We're also given Young's modulus and alpha, which is the coefficient of thermal expansion. So let's write down what we know. We know the initial temperature, final temperature. We also know that the total displacement is 0.1 millimeter. So this rod CD is eventually going to expand and move 0.1 millimeter up to the point where it's going to touch up against this rod assembly. So we also know that total displacement is displacement due to axial deformation plus displacement due to thermal expansion. And axial is PL over AE, and thermal is alpha delta TL. And the total displacement is this 0.1 millimeter. So what do we know? We know the length, we know the area, we know E, we're given alpha, we know delta T, and we know L. So the only thing that we need to determine is P, right? Because we're looking for a normal stress. That's our end goal. And for a normal stress, we need that force P. So, like I said, at some point this rod is going to expand to the point where it's touching both ends of the assembly. So it's kind of going to be flush against the top and the bottom. So we're going to have a force PC and a force PD. And I chose to cut the bar and examine everything above. So N equals negative PC. I'm going to end up plugging that into my equation. But an important thing to remember is we only have two forces, right? PC and PD, so they're going to be equal to each other no matter what. So N equals negative PC. And I have my equation here for displacement. So all I do is I plug in my negative PC here, and then all of the other values, just length divided by pi r squared times Young's modulus plus coefficient of thermal expansion times the delta T times the length. So I end up being able to solve for PC. So PC equals 2.796 times 10 to the 5th newtons. And we said that because PC and PD are the only forces there, they're going to be equal to each other. So automatically we know what PC and PD is. Pretty straightforward. And from there on, we want to find now the normal stress. So once again, I redraw my rod, I cut it, and I end up with my normal force equals negative PC. And if you remember, normal stress equals force divided by area. So I plug that in, negative PC divided by pi r squared, and I end up with normal stress equals negative 142.3 megapascals. It's negative, so that means that the rod is in compression, right? So if it was positive, it would mean that it was in tension. Negative means that it is in compression whenever the temperature rises. Another thing to consider is that you can analyze the normal force in terms of PC or PD. Because they are equivalent, you will end up getting the same answer in this case. So it doesn't matter if you had cut the rod and looked up or if you cut it and looked down. And that's